the landscape of computational modeling, the integration of advanced artificial intelligence has emerged as a significant game changer with far-reaching consequences. It does not merely transform how we inform energy projections and scenarios, it also profoundly influences our decision-making processes and our modeling approach. On one hand, it has the potential to greatly enhance the predictive accuracy and efficiency of models across various fields, but it also raises concerns about transparency, privacy, bias, and the ethical use of AI-driven models. In this interview, I asked 4 leading scholars to give their expert opinion on the pragmatic implications and potential ramifications of the integration of advanced artificial intelligence into modeling.
In my opinion, artificial intelligence can help modelers and can support them in their work with modeling, like taking over some of the difficult number crunching work, for example. But I think it's only a contribution because the conceptualization and the really important things still have to be done by the researchers, and there are also relevant dangers of artificial intelligence. You cannot rely on that too much.
Advanced artificial intelligence has been a tremendous breakthrough for modeling. In particular, this has brought up an enormous amount of information that can be used to inform energy projections and modeling in general. However, this has come along with issues related to ethics and that relates to the use of data in modeling, which doesn't have proper guidelines at the moment.
On the one hand, we hear people sometimes these days say that with artificial intelligence they will be able to really quickly produce very extensive answers that normally if we do a modeling exercise we would have to put a lot of effort, wait a long time for the results to be there. So I see people getting excited. But then on the other hand, from the research community and also civil society, I'm a bit cautious, or I'm not entirely sure about this, because we push for open models, for transparency in order to improve the acceptance of results and of the processes that are triggered by those results. And if anything that's AI-based is initially going to be a black box, so we don't really know what's in there, and I don't think in those dimensions of acceptance that really will help us so much. And then also, I can see how in other aspects of life, AI is really reproducing stereotypes and old information, if you want. In modeling, the reason why we use it these days is to really gain understanding of innovative processes, of things that are yet to come. And if AI is ever only trained on old decisions, on old data, I'm a bit skeptical as to how much it can add to problems that are different from the past that this AI has been trained on. So yeah, maybe it's a good idea for some applications, but there's really some room and some cause for caution as well, I think.
Artificial intelligence is a new set of techniques for me as a senior researcher. It's not something I was taught in school. It's not something that I've taught to students. But now I see terrific potential in at least 2 areas that make it worthwhile for students to at least get some exposure. So one area is coping with the flood of data that we're getting on demand, on wind, on solar, because models based on artificial intelligence and machine learning are proving to be much better at predicting what will happen in the next hour, in the next day, in the next 2 weeks to, for example, net loads on the system, so you can prepare for steep ramps or surprisingly high or low loads. So this has been one very important use in forecasting. A second emerging use is in solving very large optimization models. It turns out that artificial intelligence and machine learning can perhaps not yield the exact solution you want to implement, but can get you quickly to the neighborhood of good solutions. So when you are, for example, solving a power load flow for the entire European market, an artificial intelligence model might you get somewhere near the best solution, and then traditional optimization models can take over. So this marriage of AI and traditional optimization might result in much faster and more accurate solutions for the monstrously large optimization models that we have to solve in the energy sector today.